Here's some examples from the day 29 assignment. In this problem, it says given angle B is a right angle. So they're telling us this is 90 degrees. M is the midpoint of segment AC. Prove that M is equidistant from all three vertices of A, B, and C. Use the coordinates that have been assigned in the figure to complete the explanation. So the midpoint formula, the coordinates of M are, M is 2A plus 0 over 2. And so let's see. For M, we're adding the x's, which are 0 and 2a, so that's where they got 2a plus 0 divided by 2. And add the y's, which is 2c plus 0 divided by 2. So that would give you that M is going to be 2a plus 0 is 2a divided by 2 is just a, and 0 plus 2c is 2c divided by 2 is just c, so a and c. And now using the distance formula, so the distance from M to A, if we subtract the x's, it would be 2a minus a, which gives us a squared plus c squared. Then the distance from M to B, the x of point M is just, let's see, where's B? From M to B, no, that's going to be 0, the x, because, so we already, the first one we did was this distance here, which was 2a minus a, and then 0 minus c. Now the distance here from M to B is going to be 0 minus a, which is negative a squared, which makes the a positive. Same thing here with a 0 minus c. So c, that gives us positive c squared. And then from M to C, they did the a's for us, and then this would be 2c minus c. So all the distances ended up being the same, so it is equidistant from all three vertices. Okay, given ABC is isosceles, G is the midpoint of AB. So if this is isosceles, that means that this is the same as this, which would mean that because it's isosceles, all four of those segments are the same. H is the midpoint of AC, so that's what I just finished marking. AB is congruent to AC. Okay, that's already marked. Complete the explanation to prove that GC, which is here, is congruent to HB. So let's prove that. By midpoint formula, G is in the middle of A and B. So if I were to say 2A plus 0, plus 0 divided by 2, and 2B plus 0 divided by 2, that's just 2A divided by 2, which is A, and 2B divided by 2, which is B. So G is going to be at AB. For point H, which is here, that's going to be 2A plus 4A if I add the x's. If I add the x's of A and C divided by 2, comma, 2B plus 0 divided by 2, so that's 6A over 2, which is 3A, and this is just comma B. So H is at 3A, comma B. By the distance formula, GC, so from G to C, G is at AB, so we would do A minus 4a squared plus b minus 0 squared. So a minus 4a is negative 3a squared, but it looks like they've already squared it. That would give me 9a. So there should be a 9 here. And HB would be 3a minus 0 squared plus 0 or actually it would be b minus 0. B minus 0 squared. So that's 3a squared plus b squared, which what they would want, that 3a squared ends up giving me 9a squared. So they are both the same. So CG is equal, which would mean that they're congruent. Alright, this is like a bunch of distance formula. So here's all these points, and let's prove that angle FDE is congruent to angle UST. Alright, so distance formula DE, that would be square root of negative 3 minus 3 squared plus 2 minus 3 squared, which gives me, I don't like working sideways, but it's just going to be easier for you to understand here. So that's negative 6 squared plus negative 1 squared, which is going to be square root of 36 plus 1, which is the square root of 37. EF is going to be, if you subtract the x's, 3 minus 1 squared plus 3 minus 1 squared, which equals 2 squared plus 2 squared, which equals 4 plus 4, which equals square root of 8. DF would be square root of, subtract the x's, negative 3 minus 1 squared plus 2 minus 1 squared, which equals negative 4 squared plus 1 squared, which equals square root of 16 plus 1, which equals square root of 17. ST is square root of 9 minus 3 squared plus negative 2 plus 1 squared, which equals 6 squared plus negative 1 squared, which equals 36 plus 1, which is equal to the square root of 37. So that's the same as DE. This thing won't type. 37. Come on. All right, there we go. 37. Now TU is 3 minus 5 squared plus negative 1 plus 3 squared, which is negative 2 squared plus 2 squared, which is square root of 4 plus 4, which is square root of 8. So SU is 9 minus 5 squared plus equals 4 squared plus 1 squared, which is 16 plus 1, which is square root of 17. Which that was the same as DF. So the DE is congruent to ST, AF is congruent to TU, and DF is congruent to SU. Therefore, triangle DEF is congruent to STU by side, 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 and FDE is congruent to UST since corresponding parts of congruent triangles are congruent, or what you know as CPCTC. Last example, complete this explanation to prove or disprove the statement. Okay, so let's see, JK. JK is equal to, so here's the square root, -3 minus 1 squared plus 1 minus 2 squared, which is equal to square root of -4 squared plus -1 squared, which is square root of 16 plus 1, which is square root of 17. KL is going to be square root of 1 plus 2 squared plus 2 plus 3 squared, which is equal to 3 squared plus 5 squared, which is equal to 9 plus 25, which is the square root of 34. And then finally JL, which is -3 plus 2 squared plus 1 plus 3 squared is equal to plus 4 squared, which is square root of 1 plus 16, which is square root of 17. So we have 17, 34, and 17. JK and JL have the same length. JK and JL are congruent, therefore the triangle is isosceles. Isosceles triangles have two congruent sides.